Welcome back to The Deep Dive, the show built entirely around your specific curiosity. We take your stack of sources, articles, and research and distill the absolute highest impact knowledge just for you.
Today, we are diving into a career that, it didn't just witness the birth of the modern AI revolution.
No, it practically architected it, and at the same time, it completely reshaped the way millions of people, maybe even you, first learned about this whole field.
We are, of course, talking about Andrew Meng. When you really analyze his professional trajectory, what immediately stands out is just the sheer scale.
The scale and the breadth of his influence, it's wild. It goes from academia to industry leadership and, all the way to global education.
Right. He's a British-American computer scientist, a really distinguished academic, and a major technology entrepreneur. And his focus has been, relentlessly centered on machine learning and artificial intelligence since, the late 1990s?
Okay, so let's try to unpack this. It's a truly unique and a really high-impact career. Our mission today is to understand his influence through what we're sort of defining as three foundational pillars of his work.
That's a perfect way to structure it. The first pillar, I'd say, is his leadership role in AI innovation at the very highest levels of industry.
You mean like bringing deep learning out of the research lab and into massive real-world production systems?
Exactly. Then the second pillar is his pioneering. And I think you have to say revolutionary commitment to democratizing knowledge through accessible, high-quality online education.
And the third pillar is where he is now, right? His current phase. Driving the future of AI, not just through development, but through focused investment and targeted enterprise adoption.
Yes. Basically making sure that these powerful tools actually get used effectively by businesses all over the world.
When you just look at the logos he's associated with, the impact is immediately concrete.
Oh, absolutely. We're talking about the co-founder and former head of Google Brain.
The project that famously took deep learning and just plugged it into Google's massive distributed computing infrastructure.
Then he was the former chief scientist at Baidu, where he was literally tasked with building and leading an artificial intelligence group from a small team to several thousand researchers and engineers.
And then you swing over to the education side, and he's the co-founder of both Coursera and deeplearning.ai.
Think about that. How often do you find someone who has led high-impact research at two of the world's biggest tech companies and co-founded two of the biggest online learning platforms?
It's incredibly rare. That resume just puts him right at the nexus of bleeding-edge research, industrial scale, and, global teaching.
It definitely does. And the sources all point out that his influence hasn't faded one bit. He's been named one of the Time 100 most influential people not just once, but twice.
Which is a powerful indicator of enduring relevance.
For sure. He first appeared on the list in 2013, and then again a decade later on the 2023 Time 100 AI Most Influential People list.
So that signals his consistent impact throughout the entire boom cycle of AI, from the early days of deep learning all the way to the modern generative AI era we're in now. So how does a person accumulate this much foundational influence across so many different domains? Let's trace his academic foundation, because it really seems to have established his early multidisciplinary approach.
Okay, so he was born Andrew Yan Tak Nang in London back in 1976. His parents were immigrants from Hong Kong.
And he spent his very early years there, in Hong Kong, before the family moved to Singapore in 1984.
Right. And the source material highlights that he had this early aptitude for technical subjects. He apparently learned the basics of programming from books at 6 years old.
6? That's incredible.
Yeah. He attended Raffles Institution in Singapore, which is a very prestigious school. And while he was still in high school, his focus on analytical ability, it culminated in him winning a silver medal at the International Mathematical Olympiad.
And that's not just some local competition. That is a global marker of, extraordinary analytical talent and problem-solving skills long before his career even focused on computer science.
Exactly. But here's where it gets really interesting for, the future architect of scalable AI systems. His undergraduate degree.
He went to Carnegie Mellon University, CMU, which is a total powerhouse in computer science.
And he graduated in 1997 with what we can only call the triple threat degree, a triple major in computer science, statistics, and economics.
Wow. Okay, that combination is it's highly illuminating. It feels almost predictive of his entire career.
I think so too. Computer science gives you the ability to build the systems.
Right. Statistics provides the foundational mathematical rigor you need for machine learning models.
And economics provides the framework for understanding market efficiency, business application, and crucially, how to scale these systems to impact millions of users or enterprises.
So he didn't just learn how to build, he learned where to apply it for the biggest possible impact.
And he was already applying that knowledge on a massive scale, even before he got his PhD, while he was earning his master's at MIT in 1998.
In electrical engineering and computer science, right?
Right. He built something that was, well, really foundational to how modern researchers access information even today. He developed the first publicly available automatically indexed web search engine specifically for research papers.
So a search engine just for academic papers.
Exactly. The key was the automatic indexing and the specialization in machine learning literature. The sources note this was a direct precursor to databases you might know, like CiteSeerX or Research Index.
So even back in the late 90s, he was already thinking about how to organize and leverage specialized knowledge on a huge searchable scale. He was anticipating the information overload problem long before Google was what it is today.
It shows this consistent thread, a desire to lower the barriers to knowledge, whether it's for academic papers or educational courses.
And that consistent thread led him to his doctoral work and the beginning of what you could call the Stanford years.
Yep. He got his PhD in computer science from UC Berkeley in 2002, and he studied under the highly respected Michael H. Jordan.
His thesis title alone sounds incredibly complex: Shaping and Policy Search in Reinforcement Learning. For listeners who follow the field but maybe don't specialize in that area, what was the practical significance of that work?
Okay, so reinforcement learning at its core is about training an agent like a robot or an algorithm to make a sequence of good decisions in some environment.
Usually by rewarding it for the right behaviors.
Right. But the challenge is often the learning process is incredibly slow because the agent might only get a reward way, way in the future. Eng's work on shaping introduced a new approach for providing incremental rewards.
Like a series of smaller hints along the way.
Exactly. To guide the learning agent more efficiently toward that final goal. It's about accelerating the training process by making the reward landscape easier to navigate.
And what about the policy search part?
So policy search is the method the agent uses to find that optimal set of actions. His thesis combined these methods, and it provided significant improvements in the efficiency of training complex systems like robots. It's still highly cited today because it addressed a core problem in making reinforcement learning actually practical.
After getting his PhD, he joins Stanford as an assistant professor in 2002. He moves up pretty quickly to associate professor and eventually becomes director of the Stanford AI Laboratory, or SAIL.
And his machine learning course there, CS229, it was immensely popular. We're talking sometimes enrolling over 1,000 students.
Which is just unheard of for an advanced computer science course.
His teaching ability clearly resonated. But the truly defining technical decision during his academic tenure was actually about hardware. It was a strategic move that fundamentally accelerated the entire field of deep learning.
You're talking about GPUs?
I am. Eng's group at Stanford around 2008 was one of the very first in the United States to strongly advocate for and commit to using GPUs, graphical processing units, in deep learning research.
Today, that just sounds obvious. I mean, GPUs are the lifeblood of modern AI training. But back then, why was this considered controversial and risky? Weren't GPUs just for, making video games look good?
And that's the key distinction. Traditional CPU architectures, the brains of most computers, are designed for sequential processing. They execute a few complex tasks very, very quickly.
One after the other?
One after the other. But deep learning models, they primarily rely on massive amounts of repetitive matrix multiplication, thousands and thousands of simple calculations that can be performed all at the same time.
And that's what GPUs are good at, parallel processing.
Exactly. GPUs are built with thousands of small parallel processing cores, making them far more adept at this. The rationale, as the sources note, was pure scaling. They needed a more efficient computation infrastructure to speed up their model training by orders of magnitude.
The massive scaling issues that came with big data in deep learning just required a different kind of processing power.
Precisely. And the risk wasn't just the expense or the novelty. General-purpose computing platforms built on GPUs were really difficult to program effectively for research outside of graphics. It required a huge intellectual investment from Eng's team to master this new architectural approach.
But it paid off.
It paid off spectacularly. It allowed them to tackle computational problems that were simply impossible for their peers using traditional CPU clusters. And after Eng's successful implementation, the GPU quickly became the industry standard. It proved he had foresight not just in software algorithms, but in the critical hardware infrastructure underneath.
So he made a foundational hardware bet that just dramatically accelerated the entire field. But beyond that, his group at Stanford produced some incredible, tangible research projects that left these open source legacies.
They absolutely did. There are 3 projects that really define his impact in pure robotics and machine learning research from that time.
Okay, what's the first one?
First, the Stanford Autonomous Helicopter Project. They successfully developed one of the world's most capable, model-based autonomous helicopters. And this wasn't about just remote controlling it.
No, this was complex machine learning algorithms teaching the system to fly precise, acrobatic maneuvers all by itself.
Correct. It was classic, high-visibility, cutting-edge robotics that really captured the public imagination.
Okay, what was the second project?
Second, and maybe even more influential for the industry, was the STARE project. STARE stood for Stanford Artificial Intelligence Robot.
An ambitious name.
Very. It was a long-term effort to build an AI robot that Nang envisioned could one day be in every home, performing generalized tasks. Now, while the robot itself was a vehicle for research, the major lasting outcome was the creation of the Robot Operating System, ROS.
And ROS is now the standard open-source software robotics platform used all over the world. That's another key moment of democratizing technology, right? Moving it out of the Stanford lab and into the hands of researchers and hobbyists everywhere.
It standardized how robots communicate, how their components interact, and it significantly lowered the barrier to entry for robotics research and commercial deployment.
So we have the helicopter, we have ROS. What's the third one?
The third one is a bit more on the theoretical side. From his graduate school years at Berkeley, he was involved in a landmark publication introducing latent dirichlet allocation, or LDA.
LDA, I've heard of that. It's a topic modeling algorithm.
Yes, a foundational one. In simple terms, it's a technique used in natural language processing that lets a computer automatically discover the underlying themes or topics that are present in a huge collection of documents.
So you could feed it 1 million news articles, and it could tell you that there are, say, 20 distinct topics being discussed, like sports, politics, finance, without you ever telling it what those topics are.
Exactly. And that algorithm remains highly significant in how we process large texts, organize information, and structure big data analysis today. This early work just shows N's influence spanning the full spectrum. Practical robotics with the helicopter and ROS, technical infrastructure with the GPU bet, and core machine learning theory with LDA.
The natural progression for someone who figures out how to make algorithms learn faster and build smarter systems is, well, to leave the lab and scale that knowledge up to the massive industrial level.
And that's precisely what Ng did, transitioning first to Google and then to Baidu.
The first big move was to Google Brain, which he co-founded and directed from 2011 to 2012. He was working alongside other heavy hitters like Jeff Dean, Greg Corrado, and Rajat Manga.
Right. The project's goal was essentially to rapidly apply deep learning to Google's massive distributed computing infrastructure, to turn pure research into core product functionality as fast as possible.
And this is where the famous, and I think it's fair to say, viral cat experiment happened. It's almost a pop culture reference now. But what was the technical significance that made it such a huge leap for AI?
It was a massive proof point for something called unsupervised feature learning at a scale that had never been attempted before. They used a neural network trained on a staggering 16,000 CPU cores.
16,000. That in itself is an engineering feat.
It is. But the crucial technical insight was that the network, using these deep learning algorithms, learned to recognize high-level concepts, specifically cats and human faces, just by observing 10 million unlabeled random still frames pulled from YouTube videos.
So just to be clear, no one ever told the system this is a cat. It figured out the defining features of a cat all on its own.
Correct. That is the essence of unsupervised feature learning. The system essentially self-organized all that raw pixel data into abstract features. It demonstrated the power of deep learning to extract meaning from massive unstructured data sets.
And that showed that deep learning could potentially bypass the really arduous, expensive task of human labeling,
which had historically been the biggest bottleneck for large-scale AI deployment. This had immediate implications for Google's product lines.
Absolutely. The technology developed by Google Brain was quickly integrated into Google's infrastructure, and specifically into the Android operating system's speech recognition system.
So the ability to recognize complex patterns in unstructured video data, like cat videos,
translated directly into the ability to recognize complex acoustic patterns in human speech.
Exactly. It demonstrated a seamless transition from pure novel research to consumer-facing utility that millions of people started using every day on their phones.
After proving the power of deep learning at Google, En made another significant shift. He moved east to join Baidu in China as chief scientist, a role he held from 2014 to 2017.
This was a hugely strategic move. He recognized that China offered this unique combination of vast data sets, strong government support for AI research, and a massive underserved market.
So his primary task was to lead AI research and build the company's artificial intelligence group from the ground up.
And he did. It quickly grew into a multidisciplinary team of several thousand people. This wasn't just a research role. It was about building a massive, dedicated AI corporation inside of Baidu.
What were the key strategic developments that came out of his time leading Baidu's AI efforts?
There were several, and they showcased an intent to apply AI across a bunch of diverse sectors, much like at Google. He established core research teams focusing on things like facial recognition. He also developed Melody, which was an AI chatbot designed for healthcare to help physicians collect patient history.
Interesting. And critically, his teams developed the AI platform called DuerOS. Tell us more about that. Why was it so important?
DuerOS was Baidu's conversational AI system. It was their strategic answer to Amazon's Alexa or Google Assistant. It was designed to be integrated into smart speakers, mobile devices, and eventually autonomous vehicles.
And the sources note that the speed and the scope of these developments under Eng actually positioned Baidu ahead of Google in the public discourse around AI during that specific period.
They did, particularly in crucial emerging markets and in conversational AI. It was a powerful statement. They were seen, for a time, as outpacing Google in innovation.
En then resigned in March 2017, which marked the beginning of yet another major shift in his career. He pivoted back toward entrepreneurship and, maybe most importantly, education.
It's almost as if once he proved he could build AI at scale, his next goal was to scale the knowledge itself.
That synthesis feels like the critical insight of his career. He saw AI not just as a technology to be, monopolized by a few giants,
But as a universal tool. And to ensure its universal application, the world needed universal education.
that pivot to education is, you could argue, just as impactful as his contributions to the CAT experiment or the GPU decision. He recognized really early on that the knowledge he possessed needed to be shared on a massive available scale.
Yes, and the demand was already clearly signaled. As we mentioned earlier, his machine learning course at Stanford, CS229, was the most popular on campus, sometimes with over 1,000 students.
That appetite for high-level technical content was the clear signal that set the stage for the massive open online course, or MOOC, movement.
And the roots of Coursera actually trace back even further than most people realize. They go back to 2008 when Neng started the Stanford Engineering Everywhere program, or SEE.
What was the goal of that program?
The explicit goal was to publish a number of Stanford courses online for free, including his really popular machine learning class. But Eng recognized the limitations of just, posting lecture videos. He wanted to provide a much more complete course experience.
Not just lectures, but structured materials, practice problems, and solutions.
Right, and that distinction, aiming for a complete, structured course experience, not just passive video viewing, was critical. He was inspired by existing platforms, but wanted to synthesize the best elements of teaching and technology.
The sources mention a few key inspirations.
They do. He credited Sal Khan of Khan Academy as a huge inspiration for the accessibility and the way topics were broken down. He also looked very closely at the structured learning path of lynda.com, which is now LinkedIn Learning.
For professional development.
Exactly. And critically, he looked at the collaborative, self-correcting design of the community forums on Stack Overflow for managing questions and peer learning at a massive scale.
It's so interesting that he blended professional training models with open educational resources and community support. He was doing rapid iteration and testing on the teaching approach, not just the technical platform.
Absolutely. The sources note that he even tested some of the original design practices for recording lessons and online interactivity with a local high school. He was basically A/B testing his educational delivery before committing to the massive online format. He was meticulous about it.
And this rigor led to the pivotal trial run in late 2011.
Yes. In October 2011, the applied version of his Stanford class, CS229A, was hosted on a specialized website, ml-class.org. The response was immediate and just overwhelming.
Over 100,000 students registered for that first edition.
And crucially, this wasn't just passive learning. The course included quizzes and graded programming assignments, making it one of the first truly successful massive open online courses that demanded active participation.
And this launch didn't happen in a vacuum. It was part of a larger Stanford movement that really kicked off the modern MOOC era.
Correct. That same year saw the launch of 3 highly visible Stanford MOCs in total. There was Eng's machine learning course, a databases course by Jennifer Wyndham, and an AI course by Sebastian Thrun and Peter Norvig.
And Thrun's course, that led to the genesis of Udacity.
Right. The core themes of these modern MOOCs were scale and availability. The goal was to take Stanford-caliber education out of the lecture hall and put it on the global stage. And across those initial 3 10-week courses, they awarded over 40,000 statements of accomplishment, proving that massive scale could coexist with measurable learning outcomes.
That momentum led directly to the formal launch of the platform that defined the movement.
In 2012, Eng formally co-founded Coursera with fellow Stanford computer scientist Daphne Koller. Eng initially served as CEO.
And that platform took the scale and availability themes global, partnering with universities all over the world.
It quickly became one of the leading MOOC sites in the world. It's a direct product of Eng's triple background: the technical ability to build the platform, the statistical insight to track learning, and the economic foresight to see the global market for knowledge.
And even as the platform grew and added thousands of courses, Eng's original material maintained an incredible level of popularity.
Absolutely dominant. As of 2019 and 2020, years after the platform was established, 3 of the most popular courses on Coursera were still his. Machine learning was number 1, neural networks and deep learning was number 2, and AI for everyone was number 5.
So his material remains the essential entry point for millions of new learners.
And he didn't stop with Coursera. After leaving Baidu in 2017, he doubled down on his educational mission with deeplearning.ai.
Continuing that mission, focusing specifically on specialized AI and deep learning curricula.
And when you tally the total impact, the numbers are just staggering. By 2023, Eng had taught an estimated 8 million individuals globally through his courses on both platforms.
8 million, that's not just education. It's a massive self-generated workforce infusion of practical AI knowledge into the global economy.
And I think the most strategically interesting course he launched after Baidu was in 2019. It's called AI for Everyone.
And this one was different. It was specifically for non-technical learners bypassing the math and the code. Why do that?
Because he realized that the ultimate bottleneck for AI adoption is no longer the technology itself.
It's the gap between the technology and the business strategy.
Exactly. AI for Everyone was designed to help C-suite leaders, managers, and policymakers grasp AI's impact on society, understand the business benefits and costs, and know how to strategically navigate the revolution. It was about creating fluent stakeholders who can properly scope and fund AI projects, not just fluent coders.
It was an attempt to scale AI fluency vertically throughout the entire organization. Okay, let's transition now to Eng's current phase, which really combines the technical expertise of Google Brain with the economic and scaling foresight of his undergraduate degree. He's now operating as an entrepreneur, a venture capitalist, and an applied AI developer.
This stage represents a crucial shift. He's moving from educating the workforce to funding and building the companies that will employ that workforce.
In January 2018, he launched the AI Fund.
Right, raising a significant $175 million in committed capital specifically to invest in, and more accurately, to create new AI startups.
So is it a traditional VC model or more of an incubator?
It operates closer to an AI venture studio model. The idea is that they don't just wait for external pitches, they identify high-impact problems and then internally incubate companies to solve them, leveraging Eng's vast network and deep learning expertise from the very beginning.
Which drastically minimizes the early execution risk. It makes the fund a powerful engine for applied AI innovation.
But he wasn't just funding. He was also directly building, through his primary venture, Landing AI.
And Landing AI has a highly specific industrial mission.
Yes. Its goal is to provide AI-powered software as a service products focused on democratizing AI technology and lowering the barrier for entrance to businesses and developers.
That echoes his long-standing commitment to accessibility. But this time it's applied specifically to complex industrial sectors that, traditionally lag in digital transformation.
And they chose industrial manufacturing as their initial focus, specifically complex computer vision for quality control.
So think about factory floors, where tiny defects are really hard for humans to catch consistently over an 8-hour shift.
Right. Landing AI uses its platform, Landing Lens, to allow manufacturers to quickly deploy AI models to spot these flaws. This focus is practical, it's measurable, and it avoids the often hyped abstract AI theories.
And he quickly secured major funding to execute that mission.
Precisely. In November 2021, Landing AI secured a massive $57 million series round. And the capital was very targeted to help manufacturers specifically adopt these computer vision technologies, which requires not just software, but intensive on-site integration and specific training for often dirty, unpredictable industrial environments.
His investment strategy through the AI fund also highlights a commitment to global reach and high-impact sectors like healthcare.
Absolutely. The fund made its first investment in India in October 2024, backing an AI healthcare startup called Jeevi.
And what does GV do?
It focuses on using AI for critical functions, assisting with diagnoses, providing treatment recommendations, and handling complex, time-consuming administrative tasks. This investment not only signals confidence in India's growing AI sector, but also aligns perfectly with Eng's vision of applying AI to improve critical public services.
And beyond his own ventures, his expertise is highly valued across a wide array of high-profile advisory and board roles. It really showcases his diverse interests.
For sure. He serves as the chair of the board for Wobot Labs, a digital psychological clinic.
Wobot uses a therapy chatbot powered by data science to provide cognitive behavioral therapy for conditions like depression. That's a high-impact application of conversational AI.
Then, in autonomous driving, he was a member of the board for Drive.ai, a self-driving car company that was successfully acquired by Apple in 2019.
Which is further evidence of his deep involvement at the highest levels of AI application in transport.
And then, cementing his status as a key figure in the global tech hierarchy, in April 2024, Amazon announced his appointment to its board of directors.
Wow, so that places him at the strategic level, advising one of the world's largest companies as the generative AI race intensifies, guiding long-term strategy for infrastructure, consumer services, and the cloud. If we zoom out now to look at the entire arc of his career, we can gauge the full scale of his legacy and influence. It's a career built not just on developing AI technology, but on communicating it and democratizing access to it.
The measurable output is just immense. He's the author or co-author of over 300 publications in robotics, machine learning, and related fields. His work is consistently cited and forms the basis for many modern AI curricula worldwide.
And he consciously took the time to write highly practical material for the wider industry community, not just for his academic peers.
Correct. That drive for practical application really shines through in his non-academic writings. He wrote the book Machine Learning Yearning, which he distributed for free.
And it's a practical guide, right? Focusing on how to structure machine learning projects.
Exactly. It wasn't about the theory. It was about the practical engineering decisions you need to make to ship an AI product. A core lesson from his time at Google and Baidu. He followed that up with the AI Transformation Playbook, which guides executive leadership at companies on how to integrate AI strategically.
This high volume of high-quality output spanning academia, industry, and education has earned him continuous recognition across 2 decades.
The accolades are pretty significant. He received the Sloan Fellowship in 2007. In 2009, he won the IJCAI Computers and Thought Award, which is the highest award in AI for a researcher under 35.
Cementing his status as a leading mind of his generation.
Then, as we noted, Time 100 Most Influential People in 2013 and again in 2023. Fortune's 40 Under 40 in 2013. A World Economic Forum Young Global Leader in 2015.
So he's consistently recognized across different phases of the AI development cycle for his impact and leadership. But let's turn to his current vision for the future of AI, particularly his highly pragmatic perspective on regulation, which has been quite vocal in recent years.
And he takes a remarkably grounded view on the existential threats that are often discussed in AI circles, specifically the doomsday scenarios.
The evil killer robots.
Right. He believes the industry and government are often distracted by evil killer robots, as he put it. The real threat, in his view, is the much more immediate and tangible challenge to the labor market caused by these machines.
The displacement and reorganization of work.
Yes. That is the socioeconomic conversation, he argues, that everyone should be having and addressing through policy and educational changes.
That reframes the debate from science fiction to socioeconomic reality. He is also a consistent advocate for technically accelerating the field itself.
Yes. Since 2017, he has consistently advocated for the shift to high-performance computing, or HPC, It's a direct continuation of his pioneering 2008 GPU advocacy. He sees computational power as the continuing bottleneck that must be overcome for the next breakthroughs.
And regarding specific regulatory efforts aimed at AI safety, particularly those that might affect smaller players and open source models, he has been an outspoken critic.
He has. He's argued that heavy-handed rules could be counterproductive. In a December 2023 interview, he highlighted that potential regulations involving reporting mandates, licensing, and liability risks could disproportionately burden smaller firms and effectively stifle innovation.
His core argument is that compliance costs are steep.
Very steep. And imposing them universally, especially on foundational open-source technologies, would only strengthen the market dominance of a few large companies, the Googles and Betas of the world, while hindering the very democratization he champions.
So the regulatory structure intended for safety might actually create a centralized, anti-competitive environment.
Precisely.
No.
He advocates for regulations that are carefully designed to target specific, proven risks rather than hypothetical ones, and that prevent obstacles to the development of beneficial AI, especially open-source models, which he views as the engine of broad innovation.
We saw this entire tension play out dramatically in California with some proposed legislation earlier in 2024.
That's the perfect case study. In June 2024, Eng expressed significant concern about a California bill that would have required developers of advanced models to implement safety mechanisms, including a mandatory kill switch.
A kill switch. And liability for models that could potentially assist in dangerous activities.
He described the bill as creating massive liabilities for science fiction risks and said that it stokes fear in anyone daring to innovate. The technical complexity and potential liability attached to requiring a kill switch for a widely distributed open-source model were cited by many opponents, including Eng, as an impossible burden.
The consensus among critics was that the bill disproportionately targeted open-source developers and smaller AI companies who just don't have the legal and financial resources of the tech giants.
Correct. And while the debate was significant and very high profile, the source material notes that the bill was ultimately vetoed by the governor in September 2024.
Which aligned with Eng's stated concerns about regulation that targets perceived science fiction risks while imposing these heavy, stifling burdens on innovators.
His entire advocacy really centers on empowering people to use AI tools, seeing this as essential for building beneficial AI applications all over the world.
What an incredibly comprehensive and multifaceted career we've tracked today. We followed Andrew Ng from a math Olympian to the academic pioneer who championed GPUs, the industry leader who co-founded Google Brain and built Baidu's massive AI division,
the educational revolutionary who co-founded Coursera and brought foundational AI knowledge to 8 million people, and now the venture capitalist focused on democratizing applied AI for businesses through the AI Fund and Landing AI.
His career trajectory, when you lay it all out, reveals one unifying, consistent philosophy that connects everything he's done.
I think so too. It's a deep-seated belief that high-level, complex technology must be democratized. He did it first by open-sourcing foundational software like ROS to standardize robotics, then by mass distribution of knowledge through MOOCs to educate the world, and now he's lowering the barrier for business adoption with platforms like Landing AI.
The goal has always been to remove the exclusivity of powerful technology.
It's not just about building the smartest models. It's about giving everyone the organizational and educational tools to use them effectively and responsibly.
Precisely. Which leaves us with a final thought for you to explore as you process all this knowledge.
Given Andrew Ng's vocal opposition to AI safety regulation that he sees as unfairly burdening smaller firms and hindering open source development, and considering his decades-long commitment to expanding access to high-performance AI tools,
how might his specific, influential vision shape the crucial balance between rapid innovation and responsible governance in the technological landscape over the next 5 years?
Will the push for democratization eventually clash with the push for centralized control and safety? It's a tension that really defines the industry, and Andrew Ng is right in the middle of that conversation, guiding both the technology and the debate.
Welcome to the debate. Today, we're delving into the career and the stated concerns of Andrew Ng. He's a figure who has moved pretty seamlessly from foundational machine learning research to leading major labs at Google and Baidu, and then to creating this massive global education movement with Coursera and deep learning AI. His influence is just undeniable.
Absolutely. And he's articulated two very different, but you could argue equally urgent, challenges for AI. On the one hand, you have this warning about a sort of societal disaster from job displacement. But on the other, he's now actively campaigning against what he sees as poorly formed policy that could choke innovation.
Exactly. So that brings us to our core question. Which concern that Andrew G. has articulated presents the more critical challenge to the future of AI? Is it the fundamental societal threat of job displacement, the whole future of work problem? Or is it the immediate, trajectory-altering risk of bad government regulation stifling open-source innovation? I'm going to argue that the threat to human labor and the systemic conversation that needs to happen around it is the most substantive and foundational challenge he identifies.
And I'll be arguing that Eng's recent, very explicit advocacy against regulation actually highlights the more pressing and, frankly, more immediately disruptive risk to the entire innovation ecosystem.
So my position is that Eng's most significant long-term contribution here is his laser focus on the profound social upheaval that AI adoption is causing. The source material captures his philosophy perfectly, I think. Eng explicitly calls the labor challenge the real threat. He emphasizes that the challenge to labor caused by these machines is a conversation that academia, industry, and government should have. Right. He sees this systemic issue. I mean, how do our economies even cope when cognitive tasks, not just manual ones, are automated? He sees that as the absolute priority. He's purposefully trying to distract us from what he calls the evil killer robots fear, and crucially, his actions really back this up. His massive effort to democratize deep learning through online courses, teaching millions of students, that's a direct, sustained, strategic investment in preparing the global workforce for what he sees as an unavoidable transition. That level of effort tells me that's where he thinks the real threat lies.
Okay, I see that. But I approach this from a perspective of, well, operational viability. While the labor issue is, yes, undeniably the largest theoretical consequence of AI success, the threat of poorly conceived regulation is the more immediate and devastating practical challenge. Regulation directly impacts the ability to build and deploy the very beneficial AI technologies that he champions, the same technologies we need to mitigate job displacement.
I mean, Nung's recent public posture is one of immediate alarm. He's voiced strong concerns that regulations on basic or open source models could, and I'm quoting here, unfairly burden smaller firms and stifle innovation. When he opposed that proposed California bill, he wasn't just, defending profits. He was warning that it created massive liabilities for science fiction risks and that it stokes fear in anyone daring to innovate. So the greatest threat right now is a political overreaction that could just halt progress entirely. If we can't innovate freely, that labor problem is guaranteed to get worse.
But we're debating the scope of the real threat. And I think the language Zheng uses is really instructive. He explicitly frames the labor challenge as fundamental. I mean, this isn't about a specific startup's profitability. This is about the stability of modern economies, the well-being of billions of workers. We're talking about an existential issue that demands this massive response from, education policy, social safety nets. The scale of that action just far exceeds the concerns over a single state legislative effort. The focus on labor is proactive. The regulatory pushback is fundamentally a defensive reactive measure. Shouldn't we prioritize the foundational challenge over what is essentially operational friction?
Yeah, but I think calling one foundational and the other just operational, I think that's a bit misleading, isn't it? The operational friction is foundational to his current goals. If we accept that AI innovation is the very mechanism we need to solve the labor crisis, creating new jobs, new tools, then anything that slows or stops that innovation is, by definition, accelerating the societal crisis.
I'm not sure I follow.
Well, the regulatory threat targets open source AI and small startups. If the development environment becomes too punitive, only the giants, the very firms Eng often criticizes for having too much power, can afford the compliance. Eng knows that restricting these small, innovative firms limits the distribution and diversity of beneficial AI. So how can we fix the future of work if we eliminate the market's capacity to even generate solutions? I mean, if the societal threat is the real threat, why isn't he a leading advocate for, say, universal basic income or massive public works programs? His primary solution is private education, which addresses the labor threat symptomatically, not systematically.
That's a fair point about private versus public solutions, but I think it misses the whole idea of democratization. Eng's response isn't about political restructuring. It's about empowerment. His career shift, moving from Google Brain to co-founding Coursera and deep learning AI, that signifies a strategic choice to prioritize human capital on a scale we've never seen before. The long-term stability you get from preparing millions for this AI-powered world, I think that outweighs the risk of some temporary regulatory friction. You can't innovate in a society that's unraveling.
I'm sorry, I have to push back on that term, regulatory friction. It is far more dangerous than just friction. And G's opposition to that California bill, the one mandating things like safety testing and kill switches for frontier models, that wasn't some academic objection. It was based on the practical fear that these policies impose compliance burdens and liabilities that are just impossible for small firms to meet.
Okay.
When he says massive liabilities for science fiction risks, what he means is that a developer of an open source model could be held liable for some catastrophic, highly improbable misuse scenario, once that model is out in the world. That's a burden only a huge established firm can absorb. This directly counters his goal of lowering the barrier for entrance. These regulations don't just slow innovation. They're an insurmountable barrier for new entrants. They stifle the open source community, which is the very engine of democratized deployment. The regulation concern is an immediate threat to the mechanism of democratization itself.
But the long-term efficacy of the education is what mitigates the generational risk. The whole democratization effort, evidenced by his MOOC success, reaching an estimated 8 million students worldwide, that is an enduring policy solution. You look at the non-technical course, AI for Everyone. It was specifically designed to help people understand AI's impact. This shows a continuous, career-long commitment to managing the human side of AI. His actions across a decade prove that preparing society for the shock is his central mission. The friction from regulating startups, while, yes, painful for the industry, is ultimately an industry problem. It's not the foundational existential threat to the global workforce that he spends most of his career trying to address.
I think we need to look closer at his most recent professional shifts, though. That's a compelling argument about the scale of the education. But have you considered that his move to the AI Fund, a huge venture capital vehicle, and landing AI fundamentally changes his priorities? NG is no longer primarily an educator. He's a VC investor. His investments in startups like that AI healthcare firm GV place him directly in the path of these new regulatory concerns. If a badly written bill creates immense liability, it could kill a promising beneficial company before it ever scales. When he publicly defends these interests, he's defending the producers of innovation. This shift suggests the immediacy of the threat to the development pipeline has escalated for him, demanding his active political engagement right now.
Well, we've certainly illuminated two very distinct yet profoundly interconnected scales of threat here, all coming from the work and advocacy of Andrew Ng.
Indeed. It feels like we're debating whether to address the long-term chronic illness, which is labor displacement, or the immediate acute injury, regulatory strangulation that risks preventing the cure from ever being developed in the first place.
I still maintain that Ng's deepest concern remains systemic, the preparation of humanity for the radical shift in labor markets. He established early on that we have to address the future of work, positioning it as the necessary conversation for everyone. His educational empire is a direct, enduring, large-scale response to this profound, long-term societal issue. And I think it's the necessary prerequisite for any stable, sustainable AI deployment. Without societal stability, innovation just has no context to thrive in.
And I still argue that while the societal challenge is grave, the more acute and immediate danger, according to his specific recent advocacy and his shift into venture capital, is the imposition of massive liabilities from regulation that stifles open source and small firms. This regulatory threat compromises the foundational development environment itself. It jeopardizes the very technologies and companies that could provide solutions to the labor challenges down the road. So one speaks to the long-term goal, the other speaks to the immediate viability of the entire AI ecosystem.
This discussion really demonstrates the complexity inherent in managing a technology like AI. It shows how an influential figure like Ng has to balance responding to these long-term societal needs with fighting immediate practical barriers to innovation.
And it shows that the definition of the critical challenge really depends on your time horizon, whether you're focused on the economic stability of the next generation or the immediate viability of the tools being built right now. This tension reveals a lot about the delicate balance needed between innovation, regulation, and societal impact. And there's clearly so much more to explore in the material.